Dear student, in today's sixth lecture of RCC, we will see the D1 type of problem in which the size of the beam will be given, the factored moment to which it is subjected is also given, grade of steel and concrete used given, and the requirement is area of steel. Now in the first problem, it is given that a beam 250 mm by 500 mm effective. So data B equal to 250 mm as the effective depth is given, we will write small d equal to 500 mm. It carries a factored moment of 140 kilonewton meter. M20 grade concrete, that means FCK is 20 Newton per mm square, and Fe 500 means Fy is equal to 500 Newton per mm square. The requirement is find AST, area of steel on tension side. Now, first job is to check whether the given section is carrying moment, that is 140 kilonewton meter, is less than mu max or not. Now for Fe 500, the value of mu max is 0. Mu max 0.133 FCK BD square. This is the constant, design constant for moment that we derived in our second lecture for Fe 500. So, substituting the values, 0.133 FCK is 20, B is 250, and D 500 mm square. So, after calculating, we get the mu max value 166.25 into 10 raised to 6 Newton mm, or 166.25 kilonewton meter. Now the actual bending moment acting mu is less than mu max. That means 140 kilonewton meter is less than 166.25 kilonewton meter. So this is okay. You can write okay. If this mu is greater than mu max, you will have to redesign the size of the beam so that it will be under reinforced section only. Remember, the mu should not be greater than mu max. This is the meaning of mu max. Mu should not, the moment acting on the beam should not be greater than mu max. It should be less. Okay. Now there are two ways to calculate AST. You can select the method that you feel easier. So method 1. I will explain the method 1 of calculating the value of AST. Now we know that XU is equal to, using that equation, CU is equal to TU. In this we know that 0.36 FCK XUB is equal to 0.87 FY AST. Now here, as AST is not known, XU is also not known, remember, because XU value depends upon the amount of area of steel. Both are not known. So what I will do, I will find the value of XU in terms of AST. So XU 0.87 FY AST divided by 0.36 FCK B. So XU is equal to 0.87, FY is 500, AST is not known, divided by 0.36, FCK is given as 20 and B is given as 250. So simplifying this, what I will get, XU is equal to 0.242 AST. XU is equal to. Now, using this relation, mu is equal to Tu into Z. Mu, that is 140 kilonewton meter. So 140 into 10 raised to 6, that is Newton m. Remember, 140 is kilonewton meter. I am converting it to Newton mm. 0.87 Fy is 500. 0.87 Fy AST into bracket D minus 0.42 XU. So this is equal to 0.87 Fy is 500, AST is not known, into bracket D is 500, small d, effective depth is 500, minus 0.42. I will substitute the value of XU here, that is 0.242 AST. Now simplify this. You will get the quadratic in AST. So this will be quadratic in AST. And after solving the quadratic, you can solve this quadratic by any method. AST we get as 761.5 mm square. Okay. This is one method. Another method of finding AST that I will explain. This was method 1. Now method 2 of finding AST. In that, I will give you one formula. AST is equal to 0.5 FCK divided by Fy into bracket 1 minus square root of 1 minus 4.6 mu divided by FCK BD square into bracket B into D. So zero point 0.5 FCK is 20, Fy is 500 into bracket 1 minus under root 1 minus 4.6 into 140 into 10 raised to 6 divided by FCK 20. B, we are having B value 250 and D 500. B 250, D 500, bracket complete, 250, that is B into D 500 again. So this is a big formula. You will have to remember it by heart, otherwise solve the quadratic in method 1. So choice is yours. You can adopt method 1 or method 2, whichever you feel easier. So from this you get AST as 760 mm square, very near to the answer by method number 1. So this is the solution. Find the AST. I will solve one more problem for you. Now in this problem, okay, now similar problem, only the values are changed. Now data given B 230 mm, effective depth small d 650 mm, carries a factored moment of mu is equal to 195 kilonewton meter, M15 and Fe415 used. So FCK is 15 Newton per mm square, Fy is 415 Newton per mm square. What is required? Find AST. Find AST. Now let us start with the solution. First of all, check with the mu max. Mu max. Now grade of steel is Fe415. For Fe415, the value of mu max is 0.138 FCK BD square. So 0.138 FCK is 15, P is 230, D is 650 square. So solving this, mu max is equal to 201.15 into 10 raised to 6 Newton mm, that is equal to 201.15 kilonewton meter. Now this mu, which is 195, is less than mu max, that is 201.15. So okay, remember, actual mu must be less than maximum mu, that is limiting mu or mu max. Now again I will solve this problem by method 1. In method 1, we calculate XU in terms of AST 0.87 Fy AST upon 0.36 FCK D. So this is equal to 0.87 into 415. AST is not known, divided by 0.36, FCK is 15 and value of B is 230. So from this XU is equal to 0.29 AST. So we got value of XU in terms of AST. Now using the relation MU is equal to TU into Z, MU 195 into 10 raised to 6 in Newton mm is equal to 0.87 Fy. Fy is 415.87 Fy AST into bracket D minus 0.42 XU. So values of Fy 415, AST is not known. Value of D is given as 650 and XU value is 0.42 into 0.29 AST. Simplify this. You will get quadratic in AST. So solving the quadratic, value of AST is equal to 1027.8 mm square. Now it is up to you again to use which method, this one or the second one in which that big formula is there. Method 2, second method of finding AST. AST is equal to 0.5 Fy upon, sorry, zero point 0.5, let me correct it, 0.5 FCK, 0.5 FCK upon Fy into bracket 1 minus under root 1 minus 4.6 into mu upon FCK BD square bracket complete B into T. So substituting the values 0.5 into 15 divided by 415 into bracket 1 minus under root 1 minus 4.6 into mu is 195 into 10 raised to 6 for Newton mm divided by FCK is 15. B value is B 230, D 650, 230 and 650. B is 230, D is 650 square, 230 into 650. So calculate this and you will get AST is equal to 1026.7 mm square. So by this second method, the answer is very nearer to the answer we got by first method. Both are correct. You can adopt any method. So I will conclude by summarizing. See, in this type of problem, the size of the beam will be given, the moment acting is given, Grade of steel and concrete is given, and the required parameter is area of steel. Now here first step is to check whether the given Mu acting on the beam is not greater than Mu max. If it is less than Mu max, then proceed to find AST. The AST can be found by method 1, that is substitute the value of XU in terms of AST in the equation Mu is equal to Tu into Z. Solve the quadratic, you will get two values of AST. Take the proper value of AST, and in another method you can use this formula to find the value of area of steel, this formula. So this complete our D1 type problem. Thank you.